All right, so here what we have is what is the pH of a 0.069 molar solution of pyridine if the base dissociation constant is Kb equals 1.7 times 10 to the negative ninth? All right, so this is a Kb solution or a basic solution, and that basic solution we're going to add to water. So I'm just going to label it as pyridine plus H2O will yield, since it's a base, it's going to dissociate into our H minus plus H pyridine. Okay, now my initial concentration of this stuff is 0.069. I don't care about the concentration of my water. Really what I care about is concentration of my hydroxide. I know that this is going to dissociate. I'm going to have a change, minus X. And therefore, my hydroxide, I'm going to have a plus X. And my H pyridine, I'm going to have a plus X as well. Now, at equilibrium, E, I'm going to have 0.069 minus X, and then X and X. I'm going to be able to set this up as Kb is equal to the concentration of hydroxide ion times H pyridine divided by the concentration of pyridine. Now I can see that my Kb value is 1.7 times 10 to the negative ninth. So this right here is kind of negligible. So I'm going to scribble that out. Now I can plug my numbers in. I know that concentration of X, or concentration of hydroxide, is X, and the concentration of H pyridine, my protonated base, is also going to be X. So I'm going to end up with X times X, or X squared, over 0.069. Okay. 0.069 times 1.7 times 10 to the negative ninth equals 1.173 times 10 to the negative 10th. I'm going to take the square root of that. And what I'm going to do is I'm going to end up with X equals 1.08 times 10 to the negative fifth. Okay, so that gives me my hydroxide concentration. And, well, I can use that to figure out my negative log of 1.08 times 10 to the negative fifth, which is the same as my POH. Okay, so I'll plug that in. And what I get is my POH equals 4.97. Now don't fall into the trap of saying, oh, well, there's my answer. This question is asking for your pH. Well, so long as you remember that pH plus POH equals 14, you're going to be in good shape. And so that means effectively pH is equal to 14 minus 4.97. And that is going to be pH is equal to 9.03. Now, quick, does that make sense? From a numeric standpoint, it does. I have a solution with a base, a weak base, and my pH is 9.03. Is that a basic pH? It is. Anything above 7 is a basic pH. Anything below 7 is acidic. And anything at 7 is neutral. All right. Well, I hope this is helpful, and I'll see you in the next question.